For space geeks like us, it was the moment we'd all been waiting for. In midsummer 2015, the New Horizons probe finally reached the distant and icy world that it had spent 9 years traveling to. As we all sat glued to our smartphones, the first images were released to the public of an orb in space, a greyish orb with a dusting of red, an orb that was, improbably, decorated with a heart-shaped field of ice. The name of that orb, of course, was Pluto, and that summer in 2015 marked the first time we humans had ever gotten up close and personal with our distant neighbour. In the years since those heady days, New Horizons data has allowed scientists to build a whole new picture of the dwarf planet. Once considered an inert ball of boring ice, we now know that Pluto is instead an active world, a world of cryovolcanoes and falling snow, of vast fields of nitrogen ice, and, well, just maybe, a subsurface ocean. A world, in short, that's begging for the astrographics treatment. Far out on the icy edges of our solar system, just beyond the orbit of Neptune, lies a strange and obscure realm. Known as the Kuiper belt, it's made up of scattered frozen objects quietly turning in the darkness. Most of these objects are relatively small. Perhaps 1 trillion or more exist that measure under 100 kilometers, while thousands more exist in the 100 to 500 kilometer range. But it's when you look at the handful of Kuiper belt objects over 500 kilometers that things begin to get really rather interesting. It's here that you'll find strange worlds like the egg-shaped Haumea that spins so fast its shape is distorted. Here too that you'll find Quora with its impossible rings, alongside other dwarf planets like Makamache and Eris. Yet even among these fabled, little studied worlds, there's one object that towers above them all. With a diameter of 2,376 kilometers, or roughly 1,400 miles in Harry Potter measurements, Pluto is the largest known KBO. Not the most massive, that honor goes to Eris, but in terms of sheer size, it leads the field. It's also by far the most interesting. Back when Clyde Tombaugh first discovered Pluto in 1930, scientists assumed that it must be a dead world. So far from the sun, the thinking went, there was no way it could be anything but an inert chunk of ice, the celestial equivalent of a particularly boring Sunday afternoon. But since the New Horizons probe visited in 2015, we've been able to see just how wrong all those 20th century science types were. Far from being dull, Pluto is one of the most fascinating bodies in the solar system. If you were to somehow fly a craft at low altitude over its surface, you would see great mountains rising nearly 3,000 meters into the air. Ranges on par with Slovakia's high Tatras, their tops and sides dusted with snow. Not that these Plutonian mountains would have much in common with their Slovak brethren. Rather than rock, these mountains are made of water ice, frozen as hard as granite by Pluto's minus 240 Celsius temperature. Nor are they topped by regular snow, but by methane that's frozen in the atmosphere. And speaking of atmosphere, Pluto has one that's likewise reminiscent of Earth. According to NASA, the skies would appear blue from the planet's surface. However, that is pretty much where the similarities end. Unlike Earth's atmosphere, Pluto's is made of nitrogen, methane, and CO2. Unlike Earth's, it also freezes as the planet retreats from the sun, falling to the ground as snow. For this bit of eccentricity, we can blame Pluto's orbit. While it's common to see Pluto's distance from the sun listed as 40 AU on average, that on average part covers up some pretty wild variations. Over the 248 years that it takes Pluto to go traipsing around our star, it can go from being as far as 49 AU away to as close as 30. Since 1 AU is the distance from our Earth to the Sun, that's a hell of a change. For comparison, Uranus's orbit is an average of 19.8 AU. Place Pluto where our planet 7 is, and it would swing all the way into the sun and back out again on each orbit. In fact, Pluto's path is so elongated that it spends 2 decades of every orbit closer to the sun than Neptune. So, if you were in school between the years 1979 and 1999, which I was, just know that every science fair solar system model that you built with Pluto at the back is actually wrong. Not that its elongated orbit is the only odd thing about our favorite dwarf planet. Unlike most major celestial bodies, Pluto doesn't rotate from west to east but east to west. That means to any human hiking in its mountains, the sun would seem to travel backwards across the sky. Of all the planets, only Venus and Uranus likewise have reverse rotation. But Pluto mixes things up even further by being so tilted that it practically lies on its side, less pirouetting gracefully through space and more rolling drunkenly through it like an obese Brendan Fraser tumbling down a hill. But this is still just the basic stuff. A quick sketch of Pluto's quirkiness to get you excited for the main exhibition. Because it's only when we finally turn our attention to the dwarf planet's surface that things begin to get really sci-fi. In the photos New Horizons beamed back to us, it's possible to make out pockmarks on Pluto's surface, impact craters up to 260 kilometers in diameter. This in itself is not all that unusual. Our moon, for example, is studded with impact craters, as are the surfaces of Mars, Mercury, and that of lovable underdog dwarf planet Ceres. Where Pluto is different, though, is that these craters aren't found everywhere. Out on the dwarf planet's plains, you could trek for days over nitrogen snow in your fancy spacesuit and never once encounter an impact site. In places where there are craters, they might be vanishing. Some have signs, as NASA puts it, of erosion and filling. Now, this is interesting because it suggests that tectonic processes are at work deep within the world, processes that are slowly scrubbing away ancient impacts and leaving behind something fresh. In other words, geological activity, a sign that this world is tectonically active, activity that may even include volcanism. Now, right now, there are two known worlds in our solar system that experience volcanic activity: Earth and Jupiter's moon Io. Additionally, volcanism is suspected on Venus and may be occurring on the moons Europa and Triton. That's a relatively small number of bodies considering the solar system's size, so being able to add Pluto to that list would be a major discovery, although any plutonian volcanoes would act very differently to something like Mount St. Helens. Rather than lava, Pluto's volcanoes would be spewing out ice. Known as cryovolcanism, the process is something that we've never actually witnessed, although there is plenty of evidence for it. Whereas regular volcanoes are made up of rock and basically spew liquefied rocks in the form of lava, cryovolcanoes are made up of ice and spew a kind of slushy water. Because everything is so cold though, that slushy water does to the frozen landscape what lava does to Earth. It reshapes and resurfaces it, destroying everything in its path. Like with so much on Pluto, comparisons can only get you so far. While the principle of cryovolcanism is familiar, actually watching a cryovolcano erupt would be deeply bizarre. This is how the New York Times described it. Seeing one erupt on a world like Pluto would be nothing short of surreal. The icy lava may slowly extrude from a dome's vent or fissure as a gelid mucilaginous mass, something comparable to silly putty. Yet cryovolcanism on Pluto would be more than a chance for us to witness some weird-ass space shit. It would also raise some rather intriguing possibilities. When a volcano forms on Earth, it's usually sat atop a chamber of magma. Magma that eventually bubbles out in the form of lava. Cryovolcanoes are no different, only their fuel source isn't molten rock, but rather chambers where ice has at least partially melted. Chambers filled with liquid that's warm enough to remain fluid. All of which means that something extremely precious might exist below Pluto's frozen surface. Something NASA has spent the last decade desperately hunting for all across our solar system. That something, of course, is liquid water. In recent years, it's become such a cliche to suggest celestial bodies might have subsurface oceans that XKCD even ran a comic mocking it. But just because something in science is a cliche, it doesn't mean that it's not true. After all, no one is like, gravity? What, is it working again? Give me a break. And there really are signs that multiple worlds near ours may harbour hidden liquid water. In the case of Saturn's moon Enceladus and Jupiter's moon Europa, that hidden water is all but confirmed. It's also suspected on the moons Triton and Ganymede, as well as the dwarf planet Ceres. Cool as finding liquid water in any of those places would be, though, Pluto is in a category all of its own. For one thing, a plutonian ocean so far from the sun's warming rays would be a genuine surprise, something nobody had on their space exploration bingo cards. For another, the implications would be staggering. If Pluto can conceivably house a subsurface ocean, then that would mean water is likely far more abundant in our galaxy than we realized. And that, in turn, would wildly increase our chances of one day finding non-terrestrial life. But look, before you go rushing out to buy a wetsuit, your head filled with dreams of swimming alongside funky space dolphins, we should warn you that the existence of a plutonian sea is far from certain. It could be there, or it could simply be a case of everyone desperately believing what they want to believe. The first thing to note is that the unusual methods for confirming hidden oceans aren't available for Pluto. For Europa and Ganymede, scientists used highly complex measurements involving the moon's magnetic fields, or in Europa's case, the magnetic field induced by Jupiter. But Pluto doesn't have a magnetosphere, and the other means we have of detecting an ocean all require a craft in orbit. A craft that, as you are probably aware, doesn't currently exist. As a result, all of our evidence for lightless seas in caverns measureless to man is circumstantial. To that point, if this were a courtroom drama, the only lawyer willing to argue the case would be Lionel Hutz. Still, the hints that are there are tantalizing enough that real astrobiologists are now really excited about what lies beneath Pluto's surface. The most tantalizing hint of all? Well, that would be Sputnik Planitia. One lobe of the dwarf planet's famous heart-shaped region, Sputnik Planitia is also a deep basin sitting on the world's equator. As PopSci explains, quote, "Basins don't form near equators unless there are areas of high density. Since Sputnik Planitia is in a hole, the mass must be located underground, and since ice is less dense than water, it would make sense for a deep pool of liquid to reside underneath a thin sheet of ice." End quote. Other evidence is the cryovolcanism that we already mentioned, as well as signs that the surface is constantly being renewed, something a subsurface ocean might be responsible for. Finally, there are geological features like fractures that could be created from water freezing below an icy shell. Compared to the fountains of water erupting from Enceladus, this is pretty slim evidence. Until we go back there, though, it's all we've got. So let's take a giant leap and assume that the subsurface ocean is really there. And that raises two important questions. One, how did it get there? And two, what does it mean? So let's tackle question number one first, shall we? In the classical model of planetoid formation, Pluto would have slowly formed from bits of dust and ice coalescing across eons. Eventually, Pluto's internal heat would have reached a point where it could melt some of the ice trapped below the surface, where it would remain warmed by radioactive decay. However, Pluto isn't thought to hold enough radioactive elements in its core to keep an ocean warm until today, nor is it feasible that unbelievable amounts of ammonia might be found there, keeping it from freezing. All of which is why, in 2020, a study in Nature Geoscience suggested Pluto hadn't formed slowly at all, but rather quickly. So fast that the heat from massive rocks crashing into one another didn't have time to dissipate. Known as a hot start, this would have allowed Pluto to retain a liquid ocean for far longer than a slow or cold formation. Whether it could have lasted up until today is another matter, but it's certainly a theory. Nor is it the only one. There are other papers we don't have time to get into, such as one suggesting pockets of gas trapped in the ice that are acting as a kind of insulation for the hidden sea. Now, before we close out this chapter, we do need to answer our second question. What would a plutonian ocean mean? The first thing to note is that Pluto is similar to other dwarf planets in the Kuiper belt. If it has an ocean, especially one created during its formation, then it's reasonable to suppose others might too. That means objects like Eris, Makemake, and Haumea could have ancient water trapped below their surfaces. It could mean that the entire outer solar system is filled with unexplored oceans. According to the principal investigator on the New Horizons mission, S. Alan Stern, quote, "Oceans are ubiquitous. Most of them are in the outer solar system, and they could be abodes for life." And on that truly epic note, it's time to turn our attention away from Pluto itself and delve into another story. A story that takes in not just humankind's history with our distant neighbor, but also one of the greatest science controversies of the last 20 years. A controversy we're certain all of you already have some pretty strong opinions on. The story of why Pluto is no longer a planet. It was a cool February day in 1930 when Clyde Tombaugh became the first person in history to glimpse Pluto. A farm boy from Illinois, Tombaugh had grown up in a world far away from the fancy observatory he now worked in, one in which his only telescopes were those he made himself out of old Buick parts. But space had been his passion, so the boy had sent his amateur sketches of Jupiter to Lowell Observatory in Arizona, hoping to land a job. He could never have guessed that job would be hunting for a missing planet. 3 years before Tombach's birth in 1903, the observatory's wealthy founder, Percival Lowell, had used irregularities in Neptune's orbit to predict that there must be a hidden planet affecting its motion. Since Neptune itself had only been discovered thanks to its gravitational effects on Uranus, this wasn't a completely out there idea. Before he died, Lowell had even estimated the rough area of the night sky the unseen planet must be hiding in. Years later, the role of continuing Lowell's search had fallen to the observatory's new hire, Clyde Tombaugh. Night after night, the Illinois farm boy took plates of this one section of the night sky, then used a blink comparator to scan them for subtle differences, for the telltale sign of a planet moving across the motionless starfield. The craziest part? His search should have been in vain. Lowell had been using an incorrect measurement of Neptune's mass, put in the correct figure, and the so-called irregularities in its orbit vanished. In other words, the search Tombaugh had inherited was built on foundations not even made of sand, but just made of fantasies. By rights, the young astronomer should not have found anything. So, you can imagine his shock when on February the 18th, 1930, Tombaugh peered through his blink comparator and saw it, a single point of light moving from one plate to the next. A point of light that we today call Pluto. The discovery of Pluto was the 1930s equivalent of Neil Armstrong touching down on the moon or watching Barbie and Oppenheimer in one sitting. The Earth was gripped by Plutomania. H.P. Lovecraft wrote it into his story, The Whisperer in the Darkness. There's some evidence Walt Disney named his cartoon dog Pluto to cash in on the craze. Yet even amidst all the excitement, there were already signs that Pluto wasn't quite what everyone hoped it was, that Tombaugh's new discovery might not be a regular planet. The journey to Pluto's demotion unfolded slowly over the next 3/4 of a century. In 1951, Gerhard Kuiper suggested that instead of a planet, Pluto might just be one object from many beyond Neptune, part of a vast belt of planetoids ringing our solar system, a belt that we today call the Kuiper belt. Nearly 3 decades later, the discovery of Pluto's moon Charon revealed Planet 9 wasn't a single entity at all. Rather, Pluto and Charon were a binary system, waltzing around a shared point in space. By 1985, astronomers were able to determine that this weird double planet system was also incredibly tiny, half the previously estimated size, smaller even than our moon. But it was a discovery in the 1990s that sealed Pluto's fate. In 1992, astronomers David C. Jewett and Jane X. Liu spotted a distant object, one that orbited far beyond Neptune. Known today as 15760 Albion, it was the first KBO ever detected, the discovery that proved Gerhard Kuiper right. And it was super awkward, because if there really were countless objects out there, who could say that there wouldn't be more the size of Pluto? Exactly a decade later, we started to discover them. From 2002 to 2005, Caltech astronomer Mike Brown, along with others like Chad Trujillo and David Rabinowitz, began imaging countless KBOs. Kara, Sedna, and Haumea were all sighted between June of 2002 and December of 2004. Unlike Albion, they were big, around 1,000 kilometers in diameter or even bigger, big enough to almost measure up to Pluto. But it would be a January 2005 discovery that really trampled on Tombaugh's legacy. On the 5th of that month, Mike Brown and his team spotted Eris, an object only a hair smaller than Pluto, but with a larger mass. And with that, Pluto's status as a planet was doomed. Just south of Vyšehrad Fortress in my adopted hometown of Prague, actually pretty close to where I live, lies a crime scene. One so notorious, it could power 1 million true crime podcasts. It was here, at the Prague Congress Center in 2006, which is so close I can see it from my house, that the International Astronomical Union, or IAU, officially killed Pluto. That year, the IAU came to its annual conference with Mike Brown's discoveries hanging over everyone. At first, there was talk that Eris might be made a full-blown planet, the 10th in the solar system. But when that proposal was rejected, the IAU instead decided on the exact opposite approach. Rather than increase the numbers of planets, they would decrease the solar system family by 1. Even back then, the vote on a new definition of planets, the vote that effectively demoted Pluto, was controversial. Taking place on that last day of the conference, it was held after all but 10% of attendees had gone home. Even then, the room was split, almost 50-50. But just as with Brexit, sometimes only slightly over 50% is all you need to make a bad idea a reality. On August the 24th, 2006, the IAU adopted 3 new rules for determining whether something is a planet. 1, it must be in orbit around the sun. Bad news for Triton, the one-time dwarf planet captured by Neptune's gravity millions of years ago. 2. The force of its own gravity must be enough to have shaped it into a sphere, so no planet status for weird egg-shaped Haumea. But it was Rule 3 that ended Pluto's 76-year reign as the 9th planet. The rule that stated any potential planet must have cleared its orbital path of other objects. Pluto, which crosses Neptune's orbit occasionally, failed to tick this box. The result? Pluto was reclassified as minor planet 134340 Pluto. Since that August day, it's been one of the handful recognized dwarf planets in our solar system, a category that also includes Eris, Makemake, Haumea, and Ceres. For Ceres' fans, this was actually a cause for celebration. After spending the first half of the 19th century as a recognized planet, Ceres had been downgraded after Neptune's discovery to a mere asteroid. Becoming a dwarf planet was a step up. For Pluto fans, though, demotion was nothing short of an outrage. Among casual admirers of our distant neighbor, this outrage was expressed by stuff like New Mexico and Illinois both declaring Pluto to still be a planet when in their night skies. Among planetary scientists, though, it was expressed in angry appeals to logic. For these guys, the idea that mere astronomers could decide what was and wasn't a planet was akin to paying more attention to the drunk guy in the bleachers than the coach on the field. As planetary scientists like Alan Stern and Philip Metzger like to point out, the definition of planet for centuries was any geologically active bodies in space, a definition that would clearly include Pluto. The problem with this, though, is that it would also include a whole lot of other bodies, not just Eris and Ceres, but also moons like Io and Titan. In fact, Metzger even declared in 2021 that he thinks there are 150 bodies in the solar system worthy of the designation planet. Alan Stern has argued there may be over 1,000. For guys like Mike Brown, this is self-evident nonsense. Despite discovering Eris, he fought hard for it and Pluto to be listed as dwarf planets. In 2016, he told The Guardian this: "I think it's important to us that there aren't that many planets. I think the word planet is like the word continent. There needs to be a smallish number of them. If every island was a continent, it wouldn't mean anything." Still, it's worth pointing out the context that the 2006 decision was taken in. Back then, all we knew of Pluto was via telescopes and remote measurements. Prior to 2015, our best image of the dwarf planet was a 2010 composite stitched together by the Hubble telescope, one in which essentially Pluto is just little more than a blur. Since New Horizons, though, we've been aware that this is an active, dynamic, exciting world, the sort of place where volcanoes erupt, clouds form, and just maybe a hidden ocean churns below the surface. Maybe planet is the wrong term, but if nothing else, Pluto is certainly a world, a remarkable one, easily deserving as much attention as Mars, Venus, or Mercury. Sadly, though, that attention is currently lacking. While Mars is the site of active missions, and Mercury and Venus are the targets of our current or future probes, there are no plans right now to send another craft to Pluto. Not that this has stopped scientists from dreaming about what future missions might look like. One of the fascinating stories about the New Horizons probe is how it was nearly rejected in its earlier stages. When Alan Stern and his team sent their proposal to NASA in 2001, the agency shot it down as being too expensive. The sole reason it ever got funded was thanks to something known as the Decadal Survey. A once every 10 years overview of what the science community thinks NASA should be focusing on, the Decadal is a big deal. While the agency isn't bound to follow its recommendations, it almost always does. In 2002, Stern launched a massive pressure campaign to get his fellow planetary scientists to put a Pluto mission at the top. He succeeded, and NASA released the funds shortly after. That little anecdote should explain the hopes Pluto fans heaped on the most recent Decadal Survey. Published last year, it was likewise targeted by a pressure campaign to get a Pluto mission selected, in this case, a mission known as Persephone. First proposed in 2020, Persephone would have been a $3 billion flagship mission that launched in 2031, then spent 27 years flying to Pluto before eventually entering orbit around the dwarf planet in 2058. There it would have remained for 3 years, mapping Pluto and its moon Charon in minute detail, conducting experiments to check for a subsurface ocean. In short, finally unlocking the secrets of one of our solar system's most fascinating, least understood bodies. Sadly, though, the 2022 pressure campaign couldn't replicate the success of the 2002 one, when the last Decadal landed a Pluto orbiter was nowhere to be seen. Instead, scientists declared NASA's #1 priority should be giving Uranus a good and hard probing. And so the Persephone dream died, along with any hopes of revisiting Pluto within our lifetimes. In many ways, this is understandable. $3 billion is a lot of money to spend, especially on a craft that won't return data until we're all old enough to have moved to a retirement condo in Florida. Even the potential subsurface ocean can't sweeten the deal. As UCLA astronomy PhD student Dakota Tyler told MIT Technology Review, there are plenty of worlds with subsurface oceans that are far closer than Pluto. Given a limited NASA budget, it makes more sense to explore planets like Europa and Enceladus first. Yet for all it might make financial sense to focus on stuff closer to home, we'd be lying if we said we weren't disappointed. As this video has hopefully shown, this distant dwarf planet isn't just fascinating for what it is, but for what it represents. As the biggest Kuiper belt object, Pluto may hide secrets that are repeated across the outer dwarf planets. What we find there could impact our understanding not just of places like Eris and Haumea, but of small, remote worlds across the cosmos, of dwarf planets orbiting distant stars, dwarf planets that may hold in their subsurface oceans all the ingredients for life. It may have fallen out of fashion in the last 2 decades, but Pluto evidently still has a lot to teach us. We can only hope that one day soon, humanity will be willing to go back there and finally learn its secrets.